going to talk about proving trig identities. Now, the whole point in proving an identity is that you are trying to manipulate the left side to match the right side. Okay? So it's not really a proof like you had in geometry class. It's an algebraic proof where you have to manipulate algebraically the left to match the right. Now, many things you're going to be doing, right, is you're going to be changing out. I have no new identities for you today at all. You can use ratios. You can use your Pythagorean identities that you have on your card, right? You can use any of those to switch in and out in order to get the other side to match. You may have to find some common denominators. You may have to multiply by reciprocals, okay? All of those different things can happen in order to get it to match. So let me show you what I mean. Let's say we have something like cosine squared x minus 1 over cosine x. And I want to get it to match negative tangent x sine x. So one thing I want to point out, first of all, is anytime you have something that's squared, you're going to want to change that out with a Pythagorean identity, right? And the other thing I want to point out is anytime there's only a single term on the bottom, you can put that underneath both of the terms, all right? So, for example, I could rewrite this as cosine squared x over cosine and then minus 1 over cosine, because you can split it up that way. First thing, though, I want to do is I'm going to switch out that Pythagorean identity, right? Cosine squared x minus 1. We're used to seeing it as 1 minus cosine squared, correct? That means sine squared. This is reversed around the other way. Yes, so this is negative sine squared. Very good. Over cosine x. Does this match negative tangent x sine x yet? So what do you have to do to get it to match? What do you think? Yeah, so we're going to take this one and split it up, because the way to do a proof is to show that each thing eventually matches. So on the top, this is negative sine x times sine x, and we have it over cosine x. So this is our first term, which is negative tangent x, and we're multiplying it by sine x. Does this now match the right-hand side of our? So we're good. That's what we're doing today. We are taking the left and matching the right. This makes sense. The last one didn't? Okay. Well, yeah. So you just got to keep working it until you get the answer, right? All right. So here we go. We're going to try another one. Here's actually example number 1. And I'm going to go back and kind of slow it down now a little bit. The first couple problems you have in your homework do not have a trig in them. So they're actual equations that you've seen before. So let's say I have 1 over x minus 1 over 2, and I want to show that this side equals 2 minus x over 2x. What, first of all, we know we have to get it from 2 fractions into a single one, which means we have to find a what? Common denominator. And what is the common denominator going to be? 2x. So we're going to multiply this first one by what number? 2, right? And we're going to multiply this one by? Awesome. So on this side, 2 times 1 is 2 over x minus 1 times x is x. Oops, over 2x, my bad, over 2x. And then I can put those together and I get 2 minus x over 2x. Do those match? Then we're done.
The first time I've seen a number in so long.
You like it, don't you, Logan?
The number part, yeah, that's okay.
Yeah. Oh, sorry. It's 418. Oh, you got another one for me? Thank you. All right. So that's the first couple of problems in the homework. You're taking actual equations and matching them. Second section in the homework, it wants to know whether it equals sign. Does it equal sign x? So you're either going to say yes or no. All right. So in this section, let's say I have f of x equals tangent x over secant x. I've got to start by simplifying this. So the first thing I'm going to do is change those into sine and cosines, right? Because I want to know if it equals sine, which means I got to have a sign in it. So this is actually tangent is sine x over cosine x. And what is secant? Good, 1 over cosine x. And so then if I'm dividing by a fraction, I'm really multiplying by the? Good. So I'm going to flip this one over. Gets rid of that one. What do you see will cancel? Cosine of x, which means this does equal sine x. So we say yes. So are we okay in this section? Awesome. No. No. You can handle it. Example number 3. Example number 3 is your 11 through 19. And it just says in the directions, prove the identity. Prove the identity. So let's do 1 minus sine x times 1 plus cosecant x. And I want to show that this equals cosecant x minus sine x. All right, so what can we do to the left-hand side? You want to box it? Okay, let's box it. That's fine. So I have 1 minus sine x times 1 plus cosecant x. 1 times 1 is 1. 1 times negative sine is negative sine x. 1 times cosecant x is cosecant x. Negative sine x times cosecant x is negative sine x cosecant x, which equals negative 1. Really? So, yep, so this diagonal adds together cosecant x minus sine x, and 1 and negative 1, they cancel. You did it. All right, so we can get a little bit tougher then because that was too easy? Okay, example number 4. Oh, I'm not going that far yet, Michael. Let's go with 1 over 1 minus cosine x plus 1 over 1 plus cosine x And I want to show that this equals 2 cosecant squared x. Not. Just a minute, hold on. Colin, what's your idea? No, that's not the same. Yeah, because he wanted to flip it. You can't do that. Yeah, because it's not the same thing. Right. So first thing, common denominator. I agree. If you've got two fractions, most of the time you're going to have to get a common denominator. So we're going to multiply this one by 1 plus cosine and this one by 1 minus cosine. On the bottom, I've got the two of them multiplied together. So on the top, 1 times that is 1 plus cosine x, and 1 times that is 1 minus cosine x. Oops, that's not a cosine that I wrote down. My bad. Try that again. 1 minus cosine x. So now on the top, we can collect like terms. Right? 1 plus 1 is 2. What happens to my cosines? They cancel. Good deal. Those are gone. On the bottom, it's the difference of squares, which is 1 minus cosine squared x. So what else can 1 minus cosine squared x be? No? Sine squared x, right? This is a Pythagorean identity. This equals sine squared. Correct. So we have 2 over sine squared x, which if I move that to the top or the inverse becomes 2 cosecant squared x. So you can't just assume things. You've got to actually do the steps to get there. Okay? So questions on this one so far? No questions? All right. Any questions before we try another one? All right. Example number 5. It'll be our last one, and I want you guys to try them. All right, let's try. Let's do a cosine x over 1 minus, no, let's go 1 plus sine x. And I want to show that this equals 1 minus sine x over cosine x. Well, it's still writing, so I'm good still. Okay, so we have to get the left-hand side to match the right-hand side. Yeah, just flip them, and they're still not the same, though. So sometimes you can multiply the top and bottom by the same thing, okay? So the first thing I'm going to recommend, I need a cosine on the bottom. So what I'm going to do is multiply the top and bottom by cosine. Whatever you do to the top, you got to do to the bottom, right? I'm going to do the same thing. So on the top, if I multiply by cosine over cosine, it's like multiplying by 1. I have cosine times cosine is cosine squared x. And on the bottom, gentlemen, on the bottom I have cosine x times 1 plus sine x. All right, so now I have a cosine that goes there. Tell me about the top for a second. What can I change that out for? Yeah, 1 minus sine squared x over cosine x times 1 plus sine x. So, we're getting closer. What can I do with the top? It's the what? Difference of squares. Thank you, Michael. So we can factor the top to 1 minus sine x times 1 plus sine x. And that's over cosine x times 1 plus sine x. So now what do you see cancels? The 1 plus sine x cancel. Right now I'm left with 1 minus sine x over cosine. Does that match that one? And we're done. Okay, so you only change the left-hand side until you get it to match the right-hand side. And I will let you only go, since I only posted to 16, you can go to 15. 15, 1 to 15 odd. You can handle it. Yeah, 1 to